So some of you may already know what the density formula looks like, but if you don't, here it is. Density is equal to the mass divided by the volume. Okay, density is equal to the mass divided by the volume. An easy way to remember that is DMV. Okay, like the Division of Motor Vehicles, where you go get your license. DMV, density equals mass divided by volume. So that's our formula. Let's look at some examples that go along with that. Okay, a cylindrical piece of wood has a diameter of 2 feet and a height of 5 feet, and the cylinder has a mass of 600 pounds. What is the density of the wood to the nearest pound per cubic foot? Use 3.14 for pi. So if they are giving us this kind of problem, okay, the density formula is simple. We need to know our mass and we need to know our volume. Well, they give us the mass. They tell us that the mass is 600 pounds. So we've got that part. That is M. Okay, M is 600 pounds. The volume, though, they don't come out and give us the volume, but they give us the dimensions of this cylindrical piece of wood. So that means we're looking at a cylinder. We need our formula sheet from yesterday. And typically, if they tell us something like this, if they say use 3.14 for pi, that probably means somewhere in the problem, you're going to need pi, okay? You're going to need pi to figure something out. So let's start by figuring out the volume here for our cylinder. The volume formula for a cylinder is pi r squared h. So they say use 3.14 for pi. They don't give us the radius. They give us the diameter. So what's the radius? 1. It's half. It's half the diameter. If the diameter is 2 feet, then the radius is 1 foot. Okay, so diameter of 2 feet means radius is 1 foot. Okay, and the height is 5 feet. They come out and give us that piece. So we've got everything we need now to figure out our volume. We just have to type that into, well, that's 1 squared. I just wrote 1, but 1 squared is 1. Okay, so 3.14 times 5 is 15.7 is our volume. Let's talk about units for a second. Okay, we're dealing with feet, and volume is always what power? How about the third power? Okay, it's the third power. Volume is always cubed because you always have 3 dimensions going on with volume. Okay, you've got like a length and a width and a height. So volume is cubed. Area is squared because we've just got 2 dimensions with area. Volume, we've got 3. All right, so let's plug into our density formula. Density equals our mass divided by our volume. Okay, so then all we have to do is divide those two amounts. 600 divided by 15.7. And it says to the nearest pound per cubic foot. So yes, that would be 38 pounds per cubic foot. 38 pounds per cubic foot. Okay, so it's a very simple formula. Density is a very simple formula, mass divided by volume. But most of these problems, you're going to have to do a little bit of work to figure out probably the volume. Okay, let's look at another one that has a little bit of a different perspective here. This problem says block A and block B have the same mass, but the density of block A is twice the density of block B. Identify the possible missing dimensions of block, that should say A. That should say block A. Okay, there may be more than one combination of answers that work. All right, so when we look at the picture here, we see that they give us all the dimensions for block B. So we can find the volume of block B. The volume of what shape is that? Look at your formula sheet. What shape does that look like? A rectangular prism. So we just multiply our length times our width times our height. So 6 times 5 is 30. 30 times 12, that gives us a volume of 360 cubic centimeters. Okay. We only have one dimension for the volume of block A. So let's go back to the problem and see what they're telling us. All right, so some keys are, it says block A and block B have the same mass. Now, here's my, advice, okay? When they say that they have the same mass, but they don't give you a mass, just make one up, okay? Just make one up. Let's just say 500, okay? Let's just say 500 for the same mass. Okay, but the density of block A is twice the density of block B. We can find the density of block B because we have its mass, we made it up, and we have its volume. So let's find the density. I'm going to label it B instead of D since it's for block B, since I've got two different ones that I'm trying to figure out. Okay, so density equals mass divided by volume. Okay, 500 divided by 360. So let's see if that comes out to a nice kind of neat number. Not really. So let's put it in fraction form. Okay, so the density of block B is 25 over 18. The density of block B is 25 over 18. What's the question actually asking us? It wants the missing dimensions of block A. Okay, so we've got to figure out the volume of block A. So we know that the density of block A is twice the density of block B. So we just found the density of block B. Let's multiply it by 2 and leave it in fraction form. Okay, so the density of block A is 25 over 9. We know its mass. It was the same as the other one, but we don't know its volume. Okay, so this was the density of A. The mass is the same as the mass of B, so we just used 500 for both of those. We don't know its volume. Now, what can we do when we have a fraction equal to another fraction? How can we solve it? We got a fraction equal to another fraction. Cross multiply, okay? Fraction equal to a fraction, we can cross multiply to solve. Okay, cross multiply and then divide. So we've got 25 times V is equal to 9 times 500. And then we divide both sides by 25. So what do we get for volume here? 9 times 500 divided by 25, 180. Okay, so the volume of block A is 180 cubic centimeters. We know that one of the dimensions is 6. We know that one of the dimensions is 6. So if we go ahead and divide that by 6, that leaves us with 30 for the width times the height. Okay, so the volume is 6 times the width times the height. So the width times the height equals 30. So we've got some choices down here. Which ones would work? 10 and 3 could work. We could put 10 here, we could put 3 here, or vice versa. Okay, so we use those. 5 and 6. Any others that would give us 30? Okay, those are the only options. Okay, those are the only options there. So, a lot of steps into that problem, okay, but it's really not that bad, okay, when you break it down. Take it slow. Anytime a problem says something like this, they have the same anything, but they don't give you a value, just make one up and use it for both of them. There's nothing wrong with that. That's gonna work out for you. All right, I want to show you a couple more examples. Okay, and then I'm going to let you work on some problems like this. Okay, a certain type of metal has a density of 5 grams per cubic centimeter. a piece of this metal has a mass of 2 kilograms. What is the volume of this piece of metal to the nearest cubic centimeter? So they give us density, they give us mass. We've got density, we've got mass. They want to know volume. So that seems pretty simple, right? D equals M divided by V. But here's where they're going to get you on this problem. Your units always have to agree. Okay, your units always have to agree. So look at what density is given in. Density is given in grams. What is our mass in? Kilograms. Okay, so we've got to convert those kilograms to grams. Well, a kilogram is 1,000 grams. So really, that is 2,000 grams. 2 kilograms is 2,000 grams. So now let's plug these into our problem. We've got density is 5, mass is 2,000. We're looking for volume. Okay. Neat thing that happens here, pretty much these two can just switch places. Okay. Volume equals 2,000 divided by 5. So that tells us that our volume is 400 cubic centimeters. Okay, so very simple, but you got to make sure that those units agree before you actually do the problem. Okay, let's look at one more here. A carpenter has 2 types of wood in his workshop. He cuts a block of each type of wood. The block of type A has volume of 60 cubic feet and a mass of 300 kilograms. The block of type B has a volume of 100 cubic feet and a mass of 600 kilograms. What is the correct comparison of the densities of the wood? Let's find our densities. They give us everything that we need. We don't have any issues with units. Both of them are in cubic feet and both of them are in kilograms, so we'll just leave them that way. So we'll say A equals mass divided by volume. So what does that give us? 5. B equals mass, 600 divided by volume. So that gives us 6. So let's look at our answer choices. It says the wood of type B is less dense. Well, which one has the bigger number? A or B? Which one's bigger? B. Okay. The bigger the number, the more dense it is. Okay. The bigger the number, the more dense it is. So B is more dense. So we eliminate answer choice A. Okay. And then we want to also eliminate answer choice D because D says wood of type A is more dense. A is not more dense. B is the more dense one. Okay. So let's look at the 2 choices that we have left. Now, don't automatically pick B just because it says B is more dense. Okay? You got to read what follows because the reason might be wrong. Okay? Wood of type B is more dense because the ratio of mass to volume is lower. Well, is that lower? Is 6 lower than 5? No. Be confident. Okay, no. So let's check C just to make sure that we haven't messed anything else up. Wood type A is less dense. A is less dense because it's less because the ratio of mass to volume is lower for type A. That is the correct reason. Less dense, lower ratio. Okay, so you got to pay attention to the details in those questions. Finding density is not hard. It's always mass divided by volume. But you got to pay attention to those details with the reasoning that they give. Okay? All right.